All right, assessing normality, really quick section. Now, I just need to talk about this section. You don't have any homework on 7.3, but I do need to let you know there is ways to assess, is your data normal? Okay, so that's what it's just kind of going through for a little bit, just to show you how would we go about, if you have a class in the future in college that asks you to, whether you take another stats class or one of your other classes has some statistics in it, and you got to say, is the stuff normal? Okay, so it's just trying to put a little filler in there. So what we can do is one method to assess normality is if we have a sample data are taken from a population that is normally distributed or normal probability plot, we can look at the observed values versus the expected z-scores. Is it approximately linear is what we would do. So, if the observed values and the expected z-score, not the actual z-score, but expected z-score, if that it has a linear model, so when we go to graph it and we do like a scatter plot, if it's got a linear model, then we can say that it is normal. All right, that's one way. The other way we do it is the normal distribution stuff, the empirical rule, where we say, okay, I got all this data, I find the mean, I find my standard deviation, and I go ahead and label that normal curve we did a couple chapters ago. And then we say, okay, I know my endpoints for my stuff. And then I say, all right, I know within one deviation, 68% of the data. So I count up how many of the data that I actually have is between 1 and -1 deviations. Is it roughly 68%? When I find out how many there are out of the total, divide it, do I get roughly 68%? Then I go out to the next deviation, 95%. I count up how many data values were observed, within 2 deviations. And then I divide. Do I get roughly about 0.95? If I get 0.93, that's not good. If I get like 0.949, okay, that's pretty darn close. I'm okay. And then we would test the third one, 99.7. And I would go through and say, okay, looking at within 3 deviations, is there about 99% of the data observed within 3 deviations? If I'm a yes, 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 then I can say it's approximately normal. Okay? So, yes, that's just time consuming. Okay? It's not a quick process. This mathematical calculation here, I'll show you it. It's not bad. I'll show you, I'm going to do a smaller thing. So, what you're supposed to do, you're supposed to go through, you're supposed to compute this formula right here. That's the expected z-score. Okay, so that's the expected z-score a value is supposed to have. So what you're supposed to do is you take, the I stands for the first, you're basically, what term are you? You're the first term, the second term, the third data point, the fourth data point, whatever it is. The N is your total number of data points that you have. Okay, what you're supposed to do is take on the top, take data point number 1, it's listed, it's characterized as 1, you go 1 minus 0.37. On the bottom, how many numbers do you have? Then you add 0.25 to it. Then you divide it. That gives you a number. And then we got to go to this table to decide what the z-score is. Okay, so now this kind of takes us out to an expected z-score. Then we go out the table. We go out to table 4 is what they call it, and I put that up in my tech talk stuff. Now we can also plot, once we get those expected z-scores, we can plot it in the lin-reg feature and do that. So I have a couple examples here, but that's a lot of data. So here's what I did. I tried to break it down easier. So I'll show you real quickly in the calculator. So we have. We got to do a minimum of 5 in order to use their table. So we'll do 5 things. Let's say we have 1, 6, 9, 12, and let's go 20. All right. So those are our 5 data things. Okay. So what we want to do is we're going to put those in L2. In L1, I just want you to put the numbers 1, 2, 3, 4, and 5. Okay, just we get to classify everybody. You're the first point, the second point, third point, fourth point, fifth point. So I'm going to split screen here. and get to my calculator and get into stats, go into my table. And again, L1, I'm going to do 1, 2, 3, 4, 5, 6. Again, I didn't need 6. Again, that's just, we're just classifying who, which one are you.
Why would you do the numbers, why would you do 1, 6, 8, 4, 5, 9, 8? What? Why would you do 1, 6, 9, 8?
Oh, I am. I'm going to put them in L2.
Why would you do
You can. It's just I'm gonna do a calculation in the calculator. I'm gonna set up a formula in a column header, and so somewhere I do need to put the generic numbers 1, 2, 3, 4, 5, 6, or in this case 5, just because I have 5 data values. It can be in L2. It's fine. I just put it in the first just so it's over there. So now I'm gonna type these in here. Again, these are just like my random sample of observed values is what this is. My 1, 6, 9, 12, and 20. Those are my observed values. Those are the observed. So now here's how we can use the TI to do a formula for us. If we go to the column header, we go to the top of the column. So we highlight the column L3 in black. In the column header for L3, I'm going to type parenthesis. So I'm going to do a parenthesis. I'm going to tell it to take, again, I put my generic order 1, 2, 3, 4, 5 in L1. So I'm going to say take L1 column. I want you to subtract 3.75 from each of those numbers. And then I'm going to close the parenthesis. And then I'm going to do division sign. And then my next parenthesis is going to be, how many numbers did I have? 5. There's 5 numbers there. And then plus 0.25. So that's what I'm going to type in up here. I'm going to say second L1 to put it, second L1, and then minus 0.375. Close the numerator, divide, open it back up. And then we're going to do 5 plus 0.25. And then now when I hit enter, it's going to do that fraction on every value from L1. Boom. Now, what I'm supposed to do, and I'll try to zoom in. What I'm now supposed to do is, these aren't my z-scores. This column right now, L3, is the percent of data to the left of that place value. Okay? So now what I'm supposed to do, and this is why I have the other iPad open on the screen, is now what I'm supposed to do is I'm supposed to go to this Z table in the center of the classroom, and I'm supposed to find, okay, where is 0.119 in the center? So 0.119 would be 0.119. As I look at here, I see 0.1112, 0.119. I gotta get further. I gotta go. Let's go over here. So it's over here. There we go. Right here, 0.119. All right, that is in the last column, or not the last column. That's the 08 column on the z-score. So then now, what is it to the? Let me focus my eyeballs. Negative 1.1. So that's got an expected. That's got a z-score of negative. So this one here has a z-score of negative 1.18. So I'm going to type that into that first cell here. All right. Oh, come on, calculator. Smaller. Negative 1.18. Then I got to do that for the next one. Okay, so the next one I got to find its percentage, 0.3095. So 0.3030303030. Do what? Yes. Now the reason why I'm showing you, just in case some of those problems, they would ask you. Yeah. Okay. So So again, what did I say this was? 3095. So 3095. So is 3095 closer to 3085 or 3121? I think it's closer to 3085. So that has a z-score of negative 5.0. Negative, sorry, 0.5. All right, next one here, 0.5. That's exactly 0. 0.5 is exactly 0. So that would be just 0. Then we come back up here, 0.6. That would be on the positive side, 0.6905. 6905. And I think that's going to be closer to the 15, the 6915. So that's going to be 0.05. Or sorry, 0.5. And then 0.5. And then the last one should be the opposite of the 1.88, negative 1. So 0.881. 0.881. There we go. Yeah, it is. It's 1.18. So 1.18. And then now what I'm supposed to do is do a linear regression on that second column, the actual. So now I need to do a lin reg with L2 and L4. And then I got to look at it. Okay? Now, can we sense? This is a long process, isn't it? Yes? Has 100% of you tuned me out? Yes? All right, so real quickly, just watch. So I go up to stat, lin reg option 4. We did that on the last test. I'm going to tell it to take L2 and L4, and I want it to graph it. And then you know what? I got to tell it to stat plot it. I got to turn it on. So let me go in here and turn on the stat plot. Now we can go L1 and L4. Stat that. So there's two things here, and I'm going to graph it too. So graph. All right, so there we have our graph. Does that look linear? Looks like a diagonal line, doesn't it? That's kind of linear. Now let's take a look at the R value. So let me turn on my stack diagnostic, and let's look at that R value. So if I go ahead, talk.
So like, you're taking the L3 values and then you're putting it in this table right here?
Not the L3, the technical, remember I got my L4 values is all those L3s converted to a z-score. The L3 is just the percentage in the middle that shows what's to the left.
So, if you like, zoom to the left, it's where you're
How did I get that? Okay, so let's go back up here. So with that in mind, so I went to find what was the first step? 0.11, 0.119. Okay, so again, the Z table, your Z scores. This is the whole number tenths out to the hundreds. Okay, so I want to find in here all my percentages. It's the data to the percent that's to the left of where I'm at. So I'm going to find 0.1119 in that center, which was way down here, way down yonder. Okay, right there. So it was technically right here.
So you take the left value.
The left value, and then add this as the hundredth place value. So that gives you this.
Yeah.
That gives you the second difference. Yeah.
Yeah. The top column is
We want to.
rocket science.
Oh, you got to do it above. You got to do it up. Sorry. You need to actually highlight that. If you do it in a cell, it'll automatically give you an error. You got to do it in the column header. All right, now, real quickly. I know we're getting ready out of time. As I get my formula, real quick. What's my R value? What's the R value on that screen up there? 0.9987? Or sorry, 0.987? 9987? See that R value? That's our correlation coefficient we did in the last chapter. Now, I'm supposed to compare that R value on table 4 to the critical value for 5 here. Is 0.9987 bigger than 0.880? Is my R value up there bigger than this one here? Yeah. So that tells me if I'm bigger than this critical value, that I know the linear model is appropriate. It's normal. All right, it's normal. All right. Now, long process. All right, ready for the fast one if you got to do it for homework? Here's the fast one. All right. All you got to do, go into your stat plot. First, you got to get your observed values. Get your observed values in a column. Which column do we put them in? Column 2, right? All right, we put our observed column in column 2. So when you go up to stat plot, I'm going to go into plot 2, turn it on. And then if I go down to my graphs, the very last graph there, that's the normal. That's the normal curve. That's the normal probability is what it is. So all I got to do is highlight that one. And then I tell it to graph, and I want to change it to L2 because all my data is in L2. My observed value is in L2. And I hit graph, and it actually does a better job calculating it than I did. So as we look, as we zoom, let me zoom out a smidge. Zoom stats. Sorry, zoom stats, zoom 9. All right. So the red dots were the second one. Is that still a straight line? Diagonal. Yeah. Okay. So if you had to assess data, is it normal? Put it in one of the columns. Turn on your stat plot. Go to the last graph for the options for graphing. That's your normal probability plot. Choose that option on the data where you put it. And then if you see a nice diagonal line, then you know it's normal. Okay? Again, the other way is the lengthy doing the empirical. All right? So just in case it pops up. Now, it's not listed as one of those things that should be on the final exam. Okay? As a look at it. They gave me sections to make sure I covered. It is not one of those ones. So just giving you extra